So let's take up the next question from Object-Oriented Programming Questions and Answers video series. Can you explain encapsulation and abstraction and what's the difference between both of them? If you remember, in our previous video we had already described, or we have already defined encapsulation and abstraction. We had said that encapsulation is nothing but you hide complexity, while abstraction is you show only you only show the necessary properties or necessary functions needed from a class. Now both of these the properties of object-oriented programming looks very similar, because at one point we are saying hide complexity, at the other point we are saying that you only show what is necessary. So the both of them look probably very similar. So what we'll do is that in this video we will actually try to see how we can implement encapsulation and how we can implement abstraction, and then we will try to see the differences between both of them. In order to understand encapsulation, here's a simple example we have chosen. So in this example, you enter the product name, you enter the product quantity, the per product cost, and it displays the total cost. Now there are two important validations which are implemented in this screen. So the first validation is that if you try to enter quantity more than 100, so if you try to enter 101, it gives you an error saying that quantity exceeds the limit. So the quantity should be less than 100. So let me less than 100 or equal to 100. So at this moment I have chosen as 100. The second is that you cannot enter the per product cost as 0. So if you try to enter the per product cost as 0, it will again flash an error. So that's one more validation which is implemented in this screen. Now let's try to understand for these two validations how the class is implemented and how the behind code or how the UI code looks like. So here's a class called as CLS product encapsulation, which is used in the UI. Now this class has two properties. One is the quantity property and the other one is the per product cost. Now there are two functions which I made in this class, and these two functions can be used to do business validations. So the first function is quantity greater. This function helps to check if the quantity is greater than 100, and it will return true if the quantity is greater than 100. There is a second function called as is product cost 0. This function helps us to detect if the product cost is equal to 0. If it is 0, then it returns true. Now let's look at the UI code. So if I go to the product to the frm encapsulation.cs, I first check by using the is quantity greater. If the quantity is greater, if this function returns true, then I throw an exception, okay, or else I go and set the quantity value. So I use the is quantity greater function to check if the quantity is greater than 100. If it is greater than 100, I throw an exception, or else I set the quantity value to the property. The second, again in the per product cost. So whenever somebody types something in the per product cost, I say that is the product cost 0, and that I detect by using is product cost 0 function. Now what's happening over here is that as a UI developer, as a UI programmer, if I want to use their class, I need to remember 4 functions. I need to remember is product cost 0 is used to check if the product cost is equal to 0, is quantity greater is used to check if the quantity is greater than 100, and then I have the other two properties, that is per product cost and quantity. So in other words, your class is pretty complex for me to use, because I need to remember 4 different kind of functions or 4 different kind of entities in order to use your class. Now if somehow I can hide both of these properties, or I can hide both of these functions, is product cost 0 and is quantity greater, if I can hide from the end user, and I just tell to the end user, you only need to set me the per product cost and quantity, and I will take the rest of the work I will take care of. So that would make our object more simplified. So in order to do that, what we'll do is that we need to change our class. So let's go to our class. The first thing what we'll do is that we'll make this private. The time we make it private, this is not exposed to the external world. And the second thing what I'll do is that I will use this is quantity greater inside this function itself. So what I've done is I have used the function inside the property set itself. So I'm saying that if this quantity is greater than 100, if this function is returning true, then just throw a new exception, or else go ahead and set the value to the quantity property. The second, again in the per product cost set, I'm using the is product cost 0, and I'm saying if the product cost is 0, then again go and throw a new exception, and in case everything is fine, just go and set the value, the set the value of the per product property. So in other words, I have taken the work of UI now inside the class itself, and I have encapsulated both these properties in a private in a private function, so that these both properties are not exposed to the UI. So now the UI just needs to send the quantity property, and they just need to set the per product cost, and the rest thing I am taking care of. In other words, this is called as encapsulation. We are hiding the complexity. The complexity means is quantity greater check and is product cost 0 check. We are hiding both of these complexities. We are taking this responsibility inside the class rather than the UI developer taking this whole responsibility. So here's my UI code, and you can see that my UI code is now pretty clean, nice and neat. It doesn't need to worry that is the quantity equal to 0, is the quantity greater than 100. All those responsibilities or all those checks are now done inside the class itself. So the UI just need to set the value of the quantity, and the rest will be taken care by the class. Even from the per product cost, it just need to set the value of the per product cost, and the rest check will be done inside the class itself. So the UI code is now pretty clean and neat. It doesn't have those if conditions, the messages, error messages, etc. So all these responsibilities are now taken care by the class. So this is called as encapsulation. So encapsulation helps us to make our class more simpler to use, or make our objects more simpler to use. And how does it make simpler? It makes the object or class simpler by taking or by hiding the complexities from the external world. For example, over here, the checks of the quantity, the checks of the per product cost is completely hidden from the external world. The external world or the UI developer now just needs to go and set the property. The rest things will be taken care by by the class itself. Let's try to understand what have we gained by encapsulation. Now, on your slide you can see that there are two code snippets. So the top code snippet shows without encapsulation, and the bottom code snippet shows with encapsulation. So you can clearly see that without encapsulation you need to interact with so many statements, while with encapsulation you need to just interact with 3 statements. So over here you need to interact with 4 different kind of functions. So you need to check is quantity greater, is product cost 0, and then set the per product cost and the quantity. But with encapsulation you just need to set the per product cost and quantity, and all the complications of checking the quantity greater or checking the product cost 0 is completely inside the object itself. So encapsulation means hiding complexity. Now there are 5 different ways by which you can do encapsulation. So the first one is private. So the time you define a function as private, which we have already done in the code, only the members of the class can have access to it. So any external members cannot have access to these functions. The second kind of access which you can implement in C# is public. All the members who can create the object of the class can have access to that property. So in other words, with the time you define public, all the members have access to all the classes, all the projects, all the properties, all the functions what you define. The third one is protected. In protected, when you define a function as protected, or when you define a property as protected, the derived classes can only access those variables, functions, or those properties. Internal means only members in the current project have access to the elements. So in other words, whatever physical project, the .csproj file or the VB file, the .vb project file you have made, only members in the current project can have access to the elements. And the final one is a mix of protected as well as protected and friend. So if you define a function in C# with protected and internal, all the members in the current project and all the derived classes can have access to those variables, functions, and properties. Remember, just a note here, friend is a keyword in VB, while internal is a keyword in C#. So both of them do the same functions, but because both of them are different languages in the whole .NET umbrella, they have different syntaxes. So there are 5 different ways by which we can implement encapsulation. So you can really fine-tune your encapsulation, that how do you want to how do you want to expose your function, to what level you want to expose your function to the UI developer. For example, the time you say private, there is no exposure at all. The time you say public, there is a full exposure. Then probably you want to fine-tune and say that only to the derived classes, then you can use protected. Probably then you want to more fine-tune and say, okay, both the derived classes and inside the project. So there are 5 different ways you can fine-tune your encapsulation level in C#. So now we have defined encapsulation, where we said that encapsulation is nothing but hiding complexity. Now let's try to see what's the definition of abstraction. Abstraction means that you need to only show what is necessary. So only show what is important or what is necessary to the end user or to the UI developer. Now if you look at both of these definitions, abstraction says show only what is necessary, while encapsulation says that hide the complexity. Both of them look very much similar. Yes, abstraction and encapsulation, they both complement each other. In other words, encapsulation helps to achieve abstraction. So abstraction is achieved through encapsulation. So the time you define your private, public, all those things, right, in encapsulation, you are actually trying to achieve abstraction. So abstraction, it's more of a design process. It's more of a thought process. So when you actually are writing your design document, or when you're defining your classes, or when you're defining your UML diagrams, that is where you actually put down abstraction. So abstraction is you can think about a theoretical thought process where you put down things in the design, on the design document, and encapsulation helps to achieve that. So both of them complement each other. Abstraction means show only what is necessary, while encapsulation means hide the complexity. So they both complement each other, and in a giving a different kind of a view, we can say that encapsulation helps to achieve abstraction. I hope that you have enjoyed this video of abstraction and encapsulation. Many of the seniors, including many of the juniors, they definitely do not know the difference between abstraction and encapsulation, but even many of the seniors are quite confused between both of these keywords. So I hope that this video has achieved what it wants to achieve, that is defining the difference between abstraction and encapsulation. In the coming up videos, we are going to see how what are interfaces, what are abstract classes, and what's the difference between interfaces and abstract classes. So stick up to this video series, and I'm sure that you will gain more insight into object-oriented programming, and you will understand object-oriented programming more better than what you have understood in your previous times.